Let's go back to our weekly materials. I recommend that you always start by watching the videos and then read and save the handout that we have for each week. So today I'm going to open this presentation. I also have the handout version of it. Presentation is broken down to individual slides, and this link just has everything in one file. So my choice is the presentation. For you, it's easier to read the handout format. Presentation for this week is called Introduction to Software Design, and we're going to discuss the topics presented in this lecture today. So essentially, a process of software design consisting of multiple tasks. Of course, when this is a non-trivial commercial software package, it requires a lot of time to complete. So you need to be able to find time to document everything, to find time to experiment with everything. Of course, you need to spend your time programming and also testing. And our course is focusing on the design aspect of software production. So it just happens to be that in today's world, all projects happening to be at the most or the highest level of complexity, and therefore they're quite non-trivial. So overall, it's challenging, and we need to go through the cycle of the initial problem analysis and then examine the overall design, which means that we need to discuss what features that we're going to include, how we're going to document everything, and we need to be able to document everything. Then we start experimenting. Finally, we begin programming, and of course, we need to do a lot of formal testing. And once the product is released to the client, we need to go through cycles of maintenance, address any issues that the user is complaining about, and all of it evolves back to the top when we start working on the second version of the product. In our course this year, we're going to try to prove that we do need a very decent time spent on the actual design of software. If you ask me what is design, my answer would be it's everything that you need to do before you actually start programming, before you actually start putting together code, which will be the system implementation. And there is no universal cookbook for any project. Obviously, things become a little easier with more experience, but ultimately there are a set of rules, good practices that you need to follow in order to be able to get ready for your next project programming phase. So there is no substitute for intelligence, experience, and taste in programming, that's for sure. And so we're going to be facing some design constraints. Constraints or difficulties, basically, stem from the abstract nature of software. The actual word abstract is used very often in programming in general because abstractness of software means that the real-world problems represented in software happen to be abstracted. Essentially, they simplify the real world down to the level at which a specific task can be solved. So here, when we talk about design constraints, basically, generalizations such as techniques that work for small projects may not necessarily apply to the larger projects. And design discussions can be formulated in terms of analogies. However, proof by analogy is fraud. It's not good proof. So again, there are other types of rules and techniques that we must follow in order to prepare to design a nice software system which can be maintainable, expandable, scalable, efficient, convenient for the users to use. And of course, we have to be aware about challenges that we may be facing. For instance, real life presents situations where there could be some delays in the plan that we trying to accomplish, and therefore, ideas such as we can have our next project done in 2 weeks may not be quite realistic. So time estimate in general in software is very challenging. When somebody is asking you to provide how much time you need to finish your project, you have to be very careful given the answer. Sometimes I calculate a reasonable time and multiply it by 2 or 3 in order to be able to come up with more realistic answer to the question about timing. And of course, once again, you have to be skeptical about any sort of universal solutions proposed. Every task happens to be very specific, and it becomes even more specific as you're trying to implement it using particular programming language, hardware platforms, and so forth.